Okay, so lesson 9.3 is all about irrigation. So the water required for agriculture. Um, it's very short, only 3 slides here. So the artificial provision of water beyond what is received by precipitation is called irrigation. So basically any extra water that is given to any agriculture or even just your lawn is irrigation. And irrigation is necessary with water-intensive crops like rice and in areas with dry climates. So there are some crops that need more water than others. Like all animals, all plants have different life requirements. So some are super water intensive. And then if we are trying to perform agriculture in areas with a dry climate where it's not going to rain much, we also need agriculture. So in Southern California, if you ever see any farms, there's lots down in Camarillo. There's lots of irrigation because it doesn't rain very much there. Irrigation is the largest use of fresh water on the planet, and so it is actually makes up 70% of the fresh water withdrawn from the ground. So 70% of the fresh water used or taken from the planet is for agriculture. So the irrigation acreage, the amount of land that we're watering, has increased globally since industrialized agriculture has become a thing. Now the amount of irrigated land is actually, your irrigation acreage is actually 2 times the size of Mexico. So there's a lot of irrigation happening. So there are problems with irrigation that we're going to talk about too, called salinization and waterlogging. Waterlogging is when we put too much water down. And what happens is if we are overwatering, then the water fills up all the pores in the soil, and so it basically drowns the plant roots. It provides them of gases that it needs, like oxygen and carbon dioxide, and suffocates them. So too much watering is not a good thing. The other problem that's less obvious is what's called salinization, and this is a buildup of salts in the surface soil layers. So there's a lot of salts as we move down the soil horizons, but at the top there isn't as much. And so what happens is if it's a pretty dry area, the water is going to be evaporating from the surface of the soil from the top horizons, and as it does that, it pulls water up from the lower horizons, and with it comes the salts. Then as the water evaporates, the salt is left behind, and now the topsoil becomes very salty. So irrigation in dry areas really increases this problem of salinization, and it can be very costly because there's a lot of lowered yield, meaning we don't get as much from our agriculture, we don't get as much of a harvest. If our land is too salty, the crops won't grow, and so it costs about $11 billion a year in global farming due to the lowered yield from salinization, salinized soil. And so the first option to prevent or to work with salinization, to correct salinization, is waiting for precipitation to wash the salt away. But especially in Southern California or other places where it's not raining a lot, that would take far too long to wait for the precipitation to wash the salts away. So that's not going to work. So we have a couple other options, which is to plant salt-tolerant plants. So there's some plants like barley or others that are okay with having that much salt. The way that they manage their ions across their roots will allow them to grow in that land. Or we can flush the land with less saline water. So saline means salty, so the ocean is saline. So we could flush it with water that has less salts in it to move that salt down to the lower horizons. But the problem is then you may lead to overwatering or waterlogging. So it's a fine balance between the two. Prevention is the best method rather than, like the title says, it's much easier to prevent than to correct. So sustainable approaches to irrigation maximize the efficiency. So sustainability is going to come up again and again, basically making this a practice that we can continue for a long, long time. So one effective way to reduce water is to better match the crops and the climate. So some crops grow better in some climates than others. For example, we would want to grow crops in Southern California or other dry areas that don't need as much water to prevent overwatering and salinization, all of those things from happening. But the problem is that because of the way that government subsidies are and the way that the agriculture industry is, we don't always grow what is best for the planet. We grow what's probably going to make the most money. So government subsidies, that means that the government will pay you to grow specific things. And so because of that, if you're growing these crops in dry areas, where, like, let's say you're growing rice in Southern California, you're going to need an awful lot of water, and that makes water artificially inexpensive. we'll come back to that one. So plants actually, and the problem is that we're watering and watering and watering these plants, but only about 40% of it is being used by plants because it's just evaporating or going other places. Like this is conventional irrigation. That water is going everywhere. But there is this thing called drip irrigation where we put the water directly on the roots. So the pipes are lower to the ground and don't spray. They drop the water directly onto the plants, which can reduce water uses. And that's all you need to know about water. To the water artificially inexpensive comment. What is happening is that normally it would cost an exorbitant, huge amount to water plants like rice in a dry climate, but what happens is since the government is assisting, providing subsidies or funds to do that, it doesn't cost as much to grow the crops there. So the water is artificially inexpensive because they're being helped to pay for it. So that is what allows us to grow these crops in a drier climate, which is really hurting the soil in the end.